In this video, we're gonna talk about the quantifiers. We're gonna see the concept and the meaning, and we're also gonna do a lot of good examples. I've got a lot of examples for you guys, so we're gonna go and see those examples. So let's start from the concept. Well, in quantifiers, there's two things. So there's two symbols that we always encounter with. So the first thing is this symbol, or the first thing is this uh, symbol. They call this ex existential quantifiers. They call this existential quantifiers. Well, what existential quantifiers means is it represents for some, or there is, or there exists, or at least one. So I don't want you guys to get confused because it is all things and examples, but the thing that I want to tell you about is existential quantifiers, or this symbol is, if it is existential quantifiers, what it means is we have to find one thing that can make our statement true. Just one thing. And if we find one thing that can make our statement true, it means that the whole thing will be true. So that's the trick with these existential quantifiers. So that's the reason that it represents for some, and there is and there exists, and at least, because at least one. I need at least one statement, or at least one. I need one thing that can make my statement true. True. And if I get true, or if I get through two or three and more, and then so be it. And that will also make my statement true then. So that's the trick with the existential quantifiers. But when we come to the universal quantifiers, so this sign over here, as you guys can see, this sign represents the universal quantifiers, and it represents for all, for every, and also for each. Well, what this means is this is kind of like the opposite to the previous one, because if I find one thing that can make my statement false, then my whole statement will be false. So that's the thing, or that's the trick with this symbol, with this universal quantifier. So all I have to do is just find one thing that can make my statement false. Want you guys, I don't want you to get confused. We're gonna see a lot of examples, and we're gonna see, I'm gonna implement the whole thing that I'm saying at the moment, so don't get confused. But the thing is this, just if it is a universal quantifier, so this one, if it is this one, the whole thing will be false if I find one thing that can make my statement false. And if it is existential quantifiers, the whole thing will be true if I find one thing that can make my statement true. So that's the trick, and that's the thing. Now let's do some examples and let's interpret what I'm saying. So let's do it. Okay, so this will be my examples. Now it says that find the true value of the examples. Well, as you guys know, quantifiers is all about finding the true values. So the first statement says that so you guys know what this sign, or what this symbol indicates, that it indicates for all. So it says that for all x, x raised to 2, or x to the power of 2 is greater than 0. So now let's just see. If I take 2 raised to 2 is greater than 0. So 2 times by 2 is 4. So 4 is greater than 0. So that is true, and this statement is true. So what if I take 1? 1 times by 2, 1 times by 1 is 1, and 1 is still greater than 0. So how? Oh, this one looks a little bit tricky. But what if I take 0? Since 0 times by 0 is 0. And is 0, do you guys think that 0 is greater than 0? No, because 0 cannot be greater than 0. 0 is always equal with 0. So my statement will be false, because I found one thing that can make my statement false. So do you get the concept? So because I found this 0 that can make my statement false, then the whole thing will be what? The whole thing will be false. But the whole, but other than zeros, you can't take even negatives. If you can't even take -1,000, it will still be greater than 0. So the only number that can make this statement false is 0. But so just because I found one number that can make my statement false, then my whole statement will be false. But what about the second one? The second one says that uh, for some x, because this indicates for some, or this is existential quantifier simple, so for that reason it represents some. So for some x, x raised to 2 is equal to 4. Well, it says that for some x, so for that reason I have to find one thing or one number that can make my statement true. So what if I take 2? Let me just take 2. Then 2 times by 2 is equals to what? It's equal to 4. And then 2 times by 2 is 4. So if I take 2, it will be 4 equals to 4. Then my statement will be what? It will be true. So that's the reason that my whole statement will be true. So let me erase the board. So this is it. This is the concept. So if you find anything, one thing that can make your statement true, then the whole thing will be true when you counter this existential quantifier. So this will be true then. So my answer will be true because I've got one number and that is true. That is 2. So 2 times by 2 is 4, and then that's it. Now what about the third one? It says that for all x, x raised to 2 plus 1 is greater than 2. Well, this one looks a little bit tricky, but it says that for all. So all I have to do is just find one thing that can make my statement false. But if I cannot find one thing that can make my statement false, then the statement will be true. So let's try. Okay, so let's try 1 and let's try 2. Okay, so what if I substitute 1? So 1 times by 1 is 1, so 1 plus 1 is 2, and 2 is greater than 2. So 2 is greater than 2. Wow, this looks a little bit messy because 2 cannot be greater than 2. So my whole statement will be false. I'm the lucky one because I get it with one try. So I try one time and I get it. I get the answer, so I'm the lucky. So this is it. 1 plus 1 is 2, so 2 cannot be greater than 2. So for that reason, it will be false because I found 2 or found one number that can make my whole statement false because I found one thing. So what about the last one? Okay, so the last one says that for some x, x raised to 2 plus 4x plus 3 is equal to 0. Well, this one needs a lot of trial, so let's try 1. So if I try 1, so 1 times by 1 is 1. 1 plus 4 times by 1 is 4, and plus 3, it will be 8. 8 is equal to 0, so this is false. A cannot be equal to 0, so we gotta try negatives. So if I try negative, this is a, so equal 8 cannot be equal to 0. So for that reason, I think I have to try negatives because I want a number that can make the whole this statement true. So let's try -1. So -1 times by -1 because it says x. So we're gonna substitute in x. So -1 times -1 is what? It's positive. It's positive one. So 1 plus 4 times by -1 is -4, and plus 3 equals to 0. So seems like now I get it because 1 plus 3 is 4, and 4 plus -4 is 0, so 0 is equal to 0. So I find it in this, and then so I find a number, and that number is -1 that can make this statement true. So for that reason, my answer will be true because I find it. It's just -1. So when you substitute -1, so -1 raised to 2 plus 4 times -1, I just did it over here, so it will be 0. So that's it, and this is the idea, the whole concept of these quantifiers and in these old things, these old symbols and signs. I hope you guys enjoyed the video, but just let me interpret what I'm saying actually just before I finish the video, because I want you guys to understand the concept deeply. So uh, this one, for the first one, what I did is just it says that for all x equals to 2 is greater than 0. So for that reason, what this means is for all of the x's, this statement is true, but it cannot be true when I substitute 0. So 0 equals to 0. It cannot be greater. So for that reason, my answer became false. What about this one? This one says that there is one number that can make the statement true, and there is, and that number was true. That number was two. It's not true actually. It was two. So what about C? Uh, it says that for all of them, this statement is true, but it cannot be true when I also substitute 1, because 1 times by 1 is 1, 1 plus 1 is 2, and 2 is equals to 2. So this statement became false for that reason, because I found a number that can make this statement false. What about the last one? The last one says that some x's, for some x's, for some x's, there's one x there's one x that can make this statement true, and it seems like there is, and that is -1. So when I substitute -1, I get 0. Also 0 is equal to 0, so this is true. So for that reason, my answer became true. So this is it, and thanks for watching, guys. And I've also got a lot of other videos on these logics and also other things that's just related to these mathematics. So thanks for watching and have a nice time.